Good evening, everybody. All right. Who's ready to talk about trees? Woo! Yes. This is probably my favorite subject. And so I'm really excited to talk trees this evening. I'm Nick Fisichella. I'm the president and CEO with Schoodic Institute at Acadia National Park. So we are a nonprofit conservation science and education organization. And together with our National Park Service colleagues, we co-lead Acadia's Research Learning Center, this wonderful campus here at the tip of the Schoodic Peninsula. And our role is to really bring the science and expertise to help inform stewardship of this cherished place, Acadia National Park, and lands and waters beyond as well. And one of our mantras is that science is for everyone and everyone can contribute to science. And so engagement is a big part of the work that we do. And of course, Acadia is mostly trees. When I look at Acadia, I see trees. And so I am quite excited for tonight's talk, which is, of course, really related to this book right here that I'm holding in my hand, Trees of Acadia. And so if you haven't picked up a copy yet, there's a chance to do so after the talk out in the lobby. So I do encourage you to pick up a copy. I keep giving mine away, but I'm going to try hard to hold on to this one. And so this is the third of our summer evening lectures, of course, the August edition. And so thank you all for being here, both in person and all the folks out there in Zoom land. And I want to thank Bar Harbor Bank and Trust. They are our corporate sponsor for the summer lecture series. And just this week, actually, we got another grant from Bar Harbor Bank and Trust. Their employees have a Casual for a Cause grant program that their staff, they get to wear jeans on Friday and they make a donation to do so. And then every quarter they vote for nonprofit organizations to make donations to. And so just this week, we got a nice donation thanks to the employees of Bar Harbor Bank and Trust. And thanks to all the supporters of Schoodic Institute that help to make our science and our education possible. And then also, I do want to mention some of the proceeds from the sale of this book actually help to support the tree science that happens here at Schoodic and in Acadia. So another good reason to pick up a book. Okay, I think that's enough from me. We have four amazing speakers tonight. And those of you here in person, you should have here the information on each of the four speakers that you'll hear from. Those online, you can definitely find that information on the webpage for tonight's lecture. And so with that, I am going to hand it over to the author of Trees of Acadia, Catherine Schmitt.
Thank you, Nick. And I do have to thank Nick for planting the seed of what became this book. When I started working for Schoodic Institute in 2018, I was really excited to get to write about trees. I had spent much of my career in the ocean and coastal zone, and so I was very excited to write about a new ecosystem. And Nick was leading a lot of experiments, many of which are still going, on the future forest in a warming world. And I also knew there was a lot of historical research on forests. Meanwhile, non-scientists were asking a lot of questions about the health of the forest and its future. And so answering those questions became this book, sharing the knowledge and the concern of scientists and Wabanaki community members whose homeland includes the trees we'll be talking about tonight. So I had a lot of help from many people along the way. And I've invited some of them to join me tonight. They are the real experts. And we're gonna just share this presentation and then we're gonna have a conversation amongst ourselves. And then we will, if there's time, open it up to questions. The book is structured around the most common species of tree in the park, with each chapter focusing on the natural history of a particular species, using actual trees and forests in the park as illustration. The subtitle of the book is The Past, Present, and Future of Park Forests. And so there's also a chronological structure to the book. And so the first part of the book is how the forest came to be and its evolution through time. This is an excerpt from chapter 1. Across these lands now known as Acadia National Park, trees are the most common scenery, forests the most common ecosystem. Trees support a diversity of wildlife, protect lakes and streams, clean the air, and pull more carbon dioxide from the atmosphere than they put back. All forests, of course, have these functions. But Acadia's forests are special for many reasons. Acadia lies within a transition zone between a temperate south and a boreal north. Warm climate species overlap with cold adapted trees. The range in elevations and proximity to the ocean create even more habitat. Protected for more than a century, the trees have aged in place with a diversity of plants and animals that only live in older forests. Nowhere else on Earth has Acadia's mix of forest types in such a small area. The number and different types of forest ecosystems is just one reason why the trees of Acadia are rare. Over and over again, I found that the trees here defy textbook descriptions. I could not rely on the majority of research. I am a science writer, and so I rely on scientific research for much of my writing. But most of it on forests is from interior regions, the Western Mountains, or industrial forest land working forests that are still being cut for timber products. And so this made my job both easier and harder. Spruce, for example, persisted in the mountains and coastal edges of the Acadia region throughout the climate shifts of the last 15,000 years, when it was much lower population in interior regions. Jack pine, meanwhile, has been here for just as long and persisted without the fire with which it is so often associated. Just two examples. There's more in the book. The core of the book is the history of human relations with the trees of Acadia, from Wabanaki stewardship, past, present, and future, through creation of the park and its management and stewardship today. And here we have to remember how much of the landscape was cleared, how trees were a major product for building materials, shipping, and fuel, how the desire for trees inspired the American Revolution, and how the destruction wrought by this desire inspired another kind of revolution in other ways of relating to the land. By 1850, more than a dozen sawmills were in operation just on Mount Desert Island, dozens more across Hancock County. Shifting market demands meant that stands of trees were cut again and again for ships, for buildings, boxes and barrels, for firewood, for lime kiln fuel. On Mount Desert Island, logging activity moved farther inland and up the mountains. And for the book, I mostly stayed on Mount Desert Island and focused on this history. And part of that is because Alan Workman had detailed the logging history here on the Schoodic Peninsula so well in his book. And so I've asked Alan to share a little bit of the logging history here at Schoodic Point.
So the trees in Acadia Park and at Schoodic differ quite a lot from what's on MDI, as does their fate. So I'm going to talk about the Schoodic area and the shoreland forest ecology from an historical point of view. The soil at Schoodic, unlike varied richer soil on MDI, is mostly the granitic gravel till and pine needle duff called Scudic soil by geologists. Almost no freshwater ponds, no big streams, small pockets of bog between granite outcropping. And this results in a shoreland forest ecology that's different from inland and indeed from MDI. Hence, the tree diversity is much less than lots of other places. There's no hemlock, there's no oak, or almost no oak, no, very little white pine, very limited deciduous species altogether. It's kind of typical what you see in the upper left. But also jack pines are a very special feature at Scudic, the ones on the upper right. They grow on almost nothing. They can grow where nothing else can survive. And also there's some very heavy trees, but mostly in down slopes where plenty of water has washed down. So there's a lot of this, but very little of the bigger trees. Question is, has this diversity, has this been, was there ever a time that the shoreland forest was once upon a time more pristine, more diverse than today? Well, in 1604, Champlain sailed into the area and he did not think so. I won't try the French. Ces îles sont couvertes de pins et sapins, autres méchants bois, very, very worthless trees, pines and so on. So he didn't think that things were very lush at the time. He looked at Scudic, he looked at the shoreland zoning. He was not so impressed, but it was fairly pristine of its type. So not so long ago, that a lot of things changed, and suddenly there's a lot less trees in the 19th century, especially. The north of Scudic Point, the peninsula, in the Scudic Peninsula in the 18th century, was peopled for no other reason than to cut the big trees. And so you can see in the red spots up there on the left, a lot of the sawmills that were going in the 18th century, in the late 18th century. And on the right, we have an early map of the 1770s in which all the population were up at the head of the estuaries and nothing down on the shores. They weren't interested in the shoreland trees that grew down there. They wanted the big trees up in the forest and shipped down to Boston for merchantable lumber. So if those trees were not the first choice, what kind of timber would be eventually cut in the Scudic Point region in this kind of ecology? Well, a simple answer came out of a deed of the 1850s. The purchase price for a lot was, of the trees that grow on the premises, 600 cords of good kiln wood and only 50 cords of merchantable spruce wood for the market. So that's 12-to-1 ratio, or about 90% of what's being cut, it's kiln wood. So what's kiln wood? It's the junk wood that is good for nothing but burning, carried all the way down the shore to the cement lime kilns in Rockport and Rockland. A major industry, major export industry for the Maine as a state, but it had to be fueled. So it was cut everywhere along shore, clear cutting all the islands and peninsulas, all the way from Boston, all the way up to St. John, New Brunswick, by wood boats that look like this one. So the first to be cut, do we have a picture of them? No, maybe. All right, so the first area of the Scudic area was the inhabited ones up in the village of at Ones Creek and Birch Harbor, and also at Fraser Point. Thomas Fraser's original founding there became a village known as Lower Harbor and a fish factory in 1835. So that brought the population and people started cutting. These are some of the big properties that you can see. And how did we get here so fast? All right. That's one area. The other big area was at the end of Scudic Point, which you see in the map on the left. And that is West Pond. And on the right-hand figure, you'll see the inlet and West Pond. That's toward the end there. And the cutting that was done needed boats to carry in to get in close on the shore, cut the trees, carry it out. They cut a canal. You can still see that entrance today. They cut it a lot wider and they sold it. They sold the rights to the Scudic Canal to each successor who came into the logging business down there. Yeah, these are some of the boats that they use, shallow draft boats like this that could scoot in that narrow area, carry out all the lumber, all the kiln wood, and carry it down to Rockland. By 1875, then, the clear-cut sections at Scudic Point, you can see them outlined here in this 1875 USGS map. And up to the north, you can see complete, all these different roads, a network of the roads in the north. People up there were cutting in smaller units. There was a big landowner that began subcontracting more and more cutting up there. So eventually that became some of the most heavily cut of all. Here by the late 1880s, that area you can see it's almost cut clear and some very thin, a bunch of birches and very few of those conifers that people want to burn up. Well, we're here and we're ready for some more logging. I think we're in prospect of even more logging.
Thanks so much, Alan. So when I first read Alan's book, History on the Edge of Scudic Point, History on the Edge of Acadia National Park, I was like, what is he talking about lime kilns? Like I just sort of like didn't quite get it. And then when I was researching all the logging and the turnover of parcels, you know, people would come in and cut and then turn it over, and it was all for the lime industry. And so it is not an exaggeration, and it's quite striking when you start looking at it all along the coast, sort of on a parcel by parcel basis. So in 1876, so you imagine this, you know, logging happening all over the coast. It's very hard for us to like picture this now. But in 1876, a century after the white pine-inspired revolution, the Ellsworth American declared that our once well-timbered country in its old growth is almost treeless, while the demands for stave lumber, box stuff, vessel wedges, and fuel for lime kilns are rapidly divesting it of its second growth. Back on Mount Desert Island, the Champlain Society, a group of Harvard student naturalists, were encountering the aftermath of logging. They expressed concern in their logbooks and with their family and friends, and later in their published articles. Edward Rand was the leader of the botanical department of the Champlain Society, and Charles Eliot was their captain, or the leader of the group. Charles Eliot was the son of Charles William Eliot. And ultimately, their concerns and actions inspired the Hancock County trustees of public reservations, who acquired and accepted donations of land on Mount Desert Island that became Acadia. And this sort of history and connection is covered in detail in the book. At Scudic, it was a sole proprietor who purchased the land, who intended to parcel and privatize, unintentionally conserving it when he died before his dream could be realized. Hancock County trustees, Treasurer George Stebbins, was recalling their motivation later on, and he said, Few people realize, except those immediately concerned, that these acquisitions were made just in time to save our forests from being devastated by the woodcutters. In acquiring these tracts for the reservations, thus saving the forests, we in some cases got ahead of the speculators and lumbermen by a few hours only. And so, as Alan also noted, if Schoodick's sort of trees of Acadia today are closer to what Champlain saw, it is thanks to a group of conservationists and all of the hundreds of individual property owners and donors who supported the efforts for conservation. It was a group effort who gathered here in 1929 at Schoodick Head to add this land to the new Acadia National Park in 1929. So chapter 7 sort of begins the section of the book on the present and future of the forests. And it's really about resilience, how the forests have grown back multiple times, have survived logging and fire, and today are some of the oldest and healthiest in the East. And we know this thanks in large part to the National Park Service Inventory and Monitoring Program and the forest and wetland monitoring crews who are led by Kate Miller. And I've asked Kate to share a little bit of what we've learned about the state of the trees. This was my slide to introduce Kate. Go ahead.
Okay, so as Catherine said, I'm Kate Miller. I work for the National Park Service Inventory and Monitoring Division. And this picture is of me taken in the same place 21 years apart, in the same plot number 1, the very first plot we ever established in our monitoring. And so I've actually been monitoring the forests in Acadia for almost half my life. That was kind of the realization I had when I put this picture together. Didn't think that when I was 26 and I was setting up the first plot. I thought that was just a seasonal job that would end soon. But anyway, so I've been doing this. So the picture on the right, I guess, in 2026, that was our 21st year of monitoring, 6th time that we were sampling this square in the forest. That again is on Schoodick Peninsula, so not far from here. And what we've kind of learned through our monitoring is kind of really encapsulated just in this single plot of what's been changing. So this is a map of the trees in plot 1 from 2006 and then 2026. So the green circles are live trees, the gray circles are dead trees, and then on the right in 2026, the little lighter green circles are trees that we gained since we started monitoring. And so when we established this plot in 2006, there were 22 live trees that are over 4 inches diameter. And from that time, we have actually lost most of them. So there are only 8 original trees from the beginning that are still alive. But we've gained 6 trees. And so this is a forest that's maturing. It's going from a mature even-age forest to a later successional forest. And this is a process that's happening all over Acadia, where the canopy is dying back, not because of poor health, but it's just part of forest dynamics, where the canopy opens up, the understory becomes loaded with regeneration, and the forest replaces itself. And so our working definition of a healthy forest is a forest that has the capacity to replace itself. And that's what's happening primarily in this plot. Let's see if I can get the mouse to over here. But there are 3 trees in particular I want to point out. So these 3 trees that have the X on them, they died between 2022 and 2026. Normally when trees die, we see them declining before they actually die. They start to lose some of their canopy, their needles aren't as thick, maybe some of their branches are dead, or they start to slow growth, they start to slow growing over time before we actually see them die. But these were healthy trees in 2022. They had full canopies in 2026, but they were dead. And so this to me, like, I think we all know last year was a pretty extreme drought. It's actually carried over into this year. We're still in drought status. this to me was the first sign of drought stress that we've seen in Acadia. I've looked through all of the data. So I was on this plot and it was a bone chilling, like, oh no, there are seemingly healthy trees that died. What's going on? I looked through all of our data. This is the only plot where I see this. So I don't think this is a widespread occurrence that's happening, but it's something that our eyes are very open now. And we should be able to capture this kind of thing through our monitoring. So again, it's in general, the forest has the capacity to replace itself. It is a healthy forest. We know that forests in Acadia are healthy. Zooming out to the park and region, because as Catherine said, they have more complex older forest structure than surrounding forests, surrounding unprotected forests. That includes like large trees, dead trees, downwoody debris or coarseweedy debris. Forests in Acadia are also largely composed of native species, and in the 21 years of monitoring, they've stayed that way. So invasive cover is very low. Invasive plant cover is very low in Acadia and has not been increasing. That's no accident. There is an active invasive plant management team in Acadia that has been maintaining that. But that's also a pattern that we have not been seeing in other parks. We've been seeing widespread invasive expansion. We also have abundant regeneration. So that's seedlings and then the bigger saplings in Acadia, and they're composed of the canopy, mostly spruce. And so that is another sign of a healthy forest. And then we are also seeing evidence of recovery from acid deposition. We see it in the soil chemistry, and we're seeing it in the fact that red spruce is increasing in the understory. So again, these are all evidence that forests in Acadia have the capacity to remain forest under current conditions and are therefore healthy. Forests in Acadia are also dynamic. This was something that I didn't expect. You see a forest, you expect slow change, and that it's just always going to look the same, and that's not true when you're looking at it every 4 years. So the forest that came back after the fire of 47 on the east side of MDI, those birch and aspen stands are succeeding to more shade-tolerant species like mostly red spruce, some red maple, and some red oak. Stands that have been spruce for a century or so are transitioning from the mature even age where all the stems are the same size, mature even age to late successional. So this is where density of trees declines overall, structural complexity increases, as does regeneration. And Kathleen does a fabulous job of describing this in the book. The book in general is just fabulous, I should say that. Strong endorsement from a tree person. All right. And then what we're also finding is that red spruce, it dominates the strata, like from the understory to the canopy, red spruce is the dominant species. And it's also increasing in its dominance over time. And so at this point, nearly half of all live trees in the park are red spruce. That's 47% of like all the trees are red spruce. And in general, this is all kind of normal and expected. The plot that I show here, this is plot 173 down by Blackwoods. And from 2010 to 2026, we've seen this transition from mature to late successional, where there's more light getting into the understory as the canopy is breaking up. So there are fewer standing trees, fewer standing live trees, but the regeneration has really grown. There's more of it and it's taller. So that orange flag, that's like the exact same place over time. So you can see how things have changed. There's also more coarseweedy debris on the ground. So that's when trees die and they lay on the ground, they become habitat for other things. And so I think maybe if you look at the 2010 picture, you're like, oh, that's a really pretty nice mossy spruce forest. And then you look at the 2026 and you're like, oh, that's really messy. Messy is good, actually. That's like what we expect. That's what we want. Mess equals structure, equals things for things, or more places for things to live. So our forests are getting messier and we are happy about it. Okay, so that's like all kind of good news. Lots of indications of healthy forests in the park, but there are also concerns, for sure. And so since we began monitoring in 2006, there are more pests and pathogens in the forest. So you've got emerald ash borer that was recently found, hemlock woolly adelgid, beech leaf disease, which a lot of people probably see in the beach, just don't look good anymore. Didn't look good because of beech bark disease, but now the leaf disease is pretty awful. Red pine scale, we lost our red pine within about a 4 or 5 year period. And most of these species aren't super abundant in the park, so you're not really seeing that much on the landscape of change. The red pine, I think, was pretty, like you could see it because it was patchy. And so this forests are still out there, they're still healthy, but we are losing some resilience. Like for every species we lose its adaptive capacity. And so we're losing kind of the forest's ability to respond to novel climate change and other stressors. And so this photo shows dead red pines among some white pine and red spruce. Interestingly, looking through the data, white pine is the species that's not dying. It's like there's almost no mortality of white pine in the park. It's 5% of the forest, so it's not like super abundant. You see them because they're big. But yeah, white pine is doing really well. Okay, so another concern that we have, which I already kind of mentioned, but drought conditions. They have been more frequently and more prolonged since our monitoring began. So this is based on the US Drought Monitor designation for Hancock County. 2025's drought was particularly rough. We hit extreme drought levels in August, which is the time where spruce needs water the most. Like spruce is happiest with a rainy August, and we had the opposite. And so, you know, this is stressful to the forest in Acadia. And then finally, red spruce comprising nearly half of the forest is kind of putting a lot of eggs in the spruce basket. And so we're concerned about spruce's ability to tolerate climate change and an unknown pest or pathogen at this point that could wipe out half the forest if it takes out spruce. And so right now it looks good. Spruce is doing well, it's increasing everywhere, but the future is a question mark. And this is where the modeling that Matthew is going to talk about is really important to give us a sense of, you know, like how much climate change do we think spruce can take? And, you know, what different scenarios might affect spruce decline or increase or stability. And then also just kind of how forests might respond if we see spruce decline, and then how effective potential management actions might help maintain forest cover. And with that, I will hand it back. Catherine.
Thank you, Kate. If the book is good, it's because I had people like Kate Miller to learn from. So the forest is experiencing rapid changes. The rate of warming in the Acadia region has increased. So the rate of warming from 2.8 degrees per century between 1895 and 2022 to now 5.2 degrees per century. It's a doubling, near doubling of the rate of warming. In the course of writing this book, Acadia experienced record-setting drought, as we just heard about, record-setting heat, precipitation, and storms. The trees are also at risk from fragmentation and loss of forests surrounding the park. All of these threats are motivation to think about helping the forest through what is called assisted forest migration, which I recently explored in a 5-part series with Maine Coast Heritage Trust last year. And these threats are also why we have to think about the future of park forests. And the research of Matthew Duveneck, a second century stewardship fellow, is so important.
Thank you, Catherine. I like the book too. So separate from this book, I recently published this paper about these novel threats in response. And the idea is, what might happen to the forests of Acadia National Park, and what might we do about it in the future? And the truth is, we don't know. We don't know what the future is. And so we explored different scenarios of sort of what if. And we used this simulation model to do that takes Acadia National Park and it breaks it into all these different individual pixels. And then within each individual pixel, we simulated, so this is a simulation of the future. It's not a time machine, but it is the best that we can do with all the available information, and looked at sort of the forest as these interconnected cells or pixels on the landscape. And then this model looked at the species-based photosynthesis, so how much photosynthesis is expected by each species, looked at the light coming into the forest, looked at competition among species and within species, looked at the soil of below ground, and then the water that was projected to come in. And we simulated this out for 100 years into the future. So a long time into the future. You know, we don't know what the forests look like tomorrow, but we attempted to do this for 100 years. Just keep that in mind. And we used a climate change projection that sort of continued this increase in emissions. So a lot of climate change over the next 100 years. And then we compared that to a static climate, sort of assuming that the climate would stay the same. And then we use this idea of novel pathogens, of some sort of an insect that we don't even know about, that nobody's even heard of, that comes in and attacks those species, specifically red spruce. The one that's got, you know, with 47% of the trees on Acadia is red spruce. So we said, all right, let's attack the red spruce in this simulation model. And then we said, okay, then if these novel pathogens attack, then what do we do about it? How might we manage for that? And that's what we sort of explored in this paper. And I'm going to show you a little bit of the results from that. So this is the simulated biomass of red spruce under over 100 years. And what you'll notice right away is that this climate change projection, let's see if I get this deal to work. So climate change is the top line and the static climate is the bottom line. You say, well, wait a minute, I thought red spruce and climate change was not a good thing. But if you look at this graph, you say that red spruce is doing pretty darn well under climate change over the next 100 years. And this is contrasted to, whoops, must have hit the back one, to balsam fir, another species here, which is simulated to not do so well. Now, in this case, these scenarios that we're looking at are what I call grow only, where the forest is growing, but I'm not attacking it with any pathogens. It's just climate change or no climate change and letting the forest grow. So what the heck is going on here? So if we go back to some of my earlier work, we see that it's due to a few different things. So this idea of the forest doing better under climate change. One of the stories has to do with the growing season length. And so under climate change, you can see this is a maps of monthly photosynthesis under climate change and no climate change. And you can see that under climate change in April, you have a lot more photosynthesis than under static climate. And if any of you were here in April, it was still kind of chilly. But under climate change, we're expected to have a much warmer start to the growing season. So that means that the growing season length in your gardens and the forest grows more. And so we end up with more photosynthesis. Now, there's a decline that happens, a projected decline that happens in the middle of the summer in, let's say, July. So you see that in July, we have a decline where it's too hot for growth under climate change. But the extended growing season in these projections outweigh the decline in the summer. So that's one reason that's going on. Another thing that's going on is land use. And so we looked at across all of New England to say, what's happening with land use? And it turns out that how much, now not Acadia, but how much across the region is timber harvesting, future timber harvesting, if we continue on the trajectory that we've been on, and future development, cutting forests down to turn into homes and such, how much does that have an effect compared to climate change? And we found that across the region, that land use had more of an effect than climate change across the region, which makes sense given how much logging happens in Maine specifically, which you can see on the map on the left. And then finally, another piece to that story, we see these are projections for the temperature over the next 100 years. You can see the temperature is going way, way up. We've seen this sort of projection in the past. These are from 4 or 5 different climate change models. But what's interesting is that if you look on the right, this is the projected annual rainfall. And you can see that it stays pretty steady over the next 100 years. And so in the models that I was using, I projected an increase in temperature, but plenty of water, which is counter to what we just learned from the recent history here at Acadia with the drought that we're still experiencing now. So keep that in mind, and frankly, these projections of water, of rainfall, these are some of the projections that are most uncertain in terms of, we don't know if it's going to rain tomorrow or not. This is a projection for rainfall out 100 years. So there's a lot of uncertainty in those projections. But sort of, you could think of it as assuming that we have plenty of water and we have an increase in temperature, we're going to have a longer growing season. So what do we do about that? Well, what's interesting, of course, is that Acadia National Park is unique in that we don't see this development pattern continuing. And we don't see the logging history continuing in Acadia National Park because it's protected land. And so what do we do in the future? Well, one thing that was a surprise perhaps was the 1947 wildfire that some people may have predicted, but it changed a lot in a very short amount of time across the Mount Desert Island. Another example is the American chestnut blight, which knocked out the American chestnut in just a few decades throughout the northeastern United States. And so we got thinking about this and said, okay, what if we simulated something that we can't even imagine happening, but we put it into the model anyway? And so we looked at a grow only, which I described, and then the slow moving pathogen. So some sort of an insect perhaps that attacks red spruce, but it moves slowly. And then another one that attacks red spruce, but it moves fast. We called it fast. And then a drought. And we said, okay, what if we reduce the amount of water in those projections after 50, 70 years, and then what happens? So we looked at these sort of 4 different scenarios. And here are some of those results. So here's the red spruce biomass over that same 100-year period. And you can see that the grow only is the black line, and that continues to increase. We saw that before. And then if we add this drought after 2080, we have a reduction in red spruce, but then it recovers because we get some more water again. And then this slow moving pathogen, it certainly reduces it, but it stays fairly steady. But this fast moving pathogen, it really, really knocks back red spruce. However, what's interesting is that the forests still are simulated to remain forest. And this is looking at the total biomass, so not just red spruce, but everything else mixed in too. And you can see that even under this fast-moving pathogen that knocks back the red spruce, you see in the blue line this increase in total biomass. And so that's other species moving in. So what species are moving in? Well, we looked at that. This is showing under that fast pathogen scenario, under 100 years of climate change, the proportion of Acadia National Park made up of these different forest types. And so the pink in this case is the spruce. And so you see this big decline in spruce from the roughly 47% that Kate mentioned down to whatever that is, 20% or something here. So then what takes its place is the question. So other forests are taking its place in the model. And we have an increase in the northern pine species, indeed even some fir, which we know doesn't do well, but the proportion of area, we get some increase in fir and maples and other species that take their place. So the flavors of the forest are changing. So what do we do about it? That's the question. And we looked at some different ideas. Should we try to resist this change and stop it from happening and keep the spruce in place by planting more spruce, for example, even after they've died? Should we accept the change and just say, okay, we're going to accept that the forests are going to change, we're going to let them be? Or should we direct the change? Should we try to get in there as gardeners do and make direct changes to the landscape? And one of the ways that we did that, and the paper explores all three, but one of the ways we did this direct change is we said, well, okay, what about these species, for example, chestnut oak, which don't grow in Acadia National Park, but you see this range boundary map is just south of Acadia. So if you look at the map, you see, well, there's a lot of it below Acadia. So what if we planted some of those species in Acadia National Park? How would they do? And even more bold, perhaps, is say, well, what about loblolly pine? Well, this species doesn't grow anywhere near Acadia. But what if we planted some of that into those sites where spruce, red spruce had been? Now, again, this is a simulation model. Nobody got hurt doing this. But this is the results of those simulations. So this is the direct scenario. And you can see that under the drought scenario, neither species did well. Whoops, I'm sorry. Neither species did well. I won't point. But under the fast pathogen scenario, under climate change, where we were losing spruce, we were able to simulate an increase in both the chestnut oak and the loblolly pine. But it took some time for that to get going. And so we don't know what the future brings, but it's important to think about these different possibilities that could happen, these sort of what if scenarios, and then how we might respond to them.
Thank you, Matthew. A note on chestnut oak. In our experiments here at Schmitt Institute, where we've planted some of these tree species in test beds and experimental plots, chestnut oak has been doing really well in coastal Maine. So it's sort of our leading on the leaderboard right now. So maybe not that unreasonable of a scenario. So the book closes with elm and ash, one of the tree species that has already been devastated by disease, and the other about to be impacted in uncertain ways. And then here again, human relations, choosing what to do, resist, accept, or direct, are not only the cause of the problem, but they are the solution. Work led by Indigenous scholars, knowledge keepers, scientists like Suzanne Greenlaw here at Schmitt Institute, and others. And so I hope that you'll read more to learn more about these stories, to remember that Acadia is mostly forest, that Acadia is because of people who, both then and now, listen to the trees and take action on their behalf. And I tried to preempt a question of what can you do? And so this is just me speaking as the author, Catherine Schmitt now, of how the trees need you and the recommendations. One is to keep forests as forests. We're actually losing forests. So after over a century of regaining forests, the Northeast region has been, and Maine have been losing forests, especially old intact forests. We want to keep those. At the same time, we want to restore degraded ecosystems and areas that have been cut. And foresters and forest ecologists have a lot of knowledge about how to do that. We want to grow native plants and plant them if you can. Use local firewood. Don't move firewood or transport it outside the local area. You want to demand alternatives to fossil fuels so we can stay in those much more favorable scenarios that Matthew presented. Support park science, like the research of the Inventory and Monitoring Division, like the work of the vegetation management crew who keep Acadia's forests healthy, who manage invasive plants, support the science here at Schoodic Institute that is helping answer so many of these questions. And then finally, get to know the trees. At a previous talk a couple weeks ago, somebody in the audience asked me what I thought the biggest threat was. And I was like trying to think really quick to answer the question. Everybody's looking at me the way that you're all looking at me right now. And I was like, what is the biggest threat? What is the biggest threat? And I stumbled through some answer about fossil fuel combustion, because solving that addresses a lot of other sort of related problems. But if I were asked tonight, I might answer differently. And I would answer, it's disconnection, and it is our lack of connection of what is outside and what is out there. And so I hope that this book inspires you to get to know the trees. And with that, I want to thank you all for listening, but we're not done, because this is going to be the fun part that I've been really, really looking forward to. And I'm going to invite my fellow presenters up to the front, and we're going to ask each other questions. We don't have a plan for this. So I think, Matt, you want to start? Okay, Matthew's going to start us off.
One of the things I appreciated about the book is the photographs. And I wonder if you could talk a little bit about the process of taking the pictures and how that went for you. They're beautiful pictures, and it's for someone that also cares about trees and takes a lot of pictures of trees. It's hard to take pictures of trees, but.
Thank you for asking and noticing the photos. There are over 100 photos that I took, and photography is a large part of my writing process. I was just telling someone last week, we were on the summit of Sergeant Mountain, and we were talking about sort of note-taking, and I tend to use my camera as my notebook, and so going through the photos later on and basing description on that rather than notes in the field, mostly because I'm moving or it's sort of quicker, but it's just also part of my process, because photography helps you to slow down and pay attention and look at things and notice things like the light coming through sort of the canopy. And so photos are a large part of my process. I also always have a camera, because we do a lot with iNaturalist here at Schoodic Institute. And so I'm always on the lookout for birds or butterflies or new flowers or things. So I always sort of have my camera ready, even when I'm walking around campus. I carry my camera, because you never know what's gonna show up. Because this is such an amazing place. So I had a lot of photos, and I wasn't sure, it wasn't originally part of the book. I didn't know if there would be photos in the book, but in talking with my editors and publishers, when I submitted the manuscript, I said, oh, I have some photos, and they decided to put them in the book. So thanks.
One of the questions that I have is because there are so many jack pines all over Schoodic, they're one of the most distinctive features of the Schoodic forest, but not so much on MDI. So I'm wondering why, the jack pines became a lead chapter in your book.
So I love this question, because this is a writer question. This is like a question because, Alan's a writer, and this is about structure. And when you're structuring a story as complex as the trees of Acadia. And so I mentioned earlier that there's a chronological structure to the book. And so with each tree species, like, what is the best story about the trees of Acadia that's represented by that tree species? And so jack pine, to me, were really about refugia and this idea of boreal cold climate trees finding refuge here, because the proximity to the ocean brings in those cooling fogs and allows a tree like jack pine, which is normally found much farther north, to persist here. And so chronologically, jack pine was helping me tell that very beginning story of how long has the forest been here? How long have these trees been here? Where did they come from after the last glaciers melted? So jack pine is like this ancient tree and was one of the earliest ones to come into the region as the glaciers melted. And so they sort of told that earlier part of this chronological structure, but there's also a spatial structure to the book, because I do use trails and try to point out trees where you can go and find them yourself in the park to get to know them. And so I started the book on Cadillac, on the summit of Cadillac Mountain at sunrise, because like obviously that's where I'm going to start the book, and the balsam fir that's at the summit. And so if you're on, there is actually a stand of jack pine on Cadillac Mountain. And then I knew I wanted to get down to Blackwoods and to red spruce for chapter 3. And so jack pine, sort of the South Ridge Trail down Cadillac Mountain, helped me get there.
Well, of course, red spruce is also the oldest, one of the oldest trees to dominate in both forests. But of course, if you want to see a lot of jack pines, go on the east side of the bike paths at Schmitt
Yeah.
Woods, and you'll see an amazing forest of jack pines living on nothing.
Yeah, it's funny because, right, I was just saying about how the fog, like the cooling fog and the moisture keeps jack pine here. But clearly it was a lot of drought when I was writing this book, because so much of my description, I used the word dry a lot, or like sear, or things just, it was like kind of, it can be, the jack pine woodlands can feel like a desert. I don't know, Kate, what you think about like the experience of jack pine woodlands. And you know some really kind of rare jack pine spots at Schoodic, right?
Yeah, so jack pine woodlands are some of the hardest ones to work in, actually. So, like, when I know we're going to a jack pine, I know it's going to be kind of a hard day. They're interesting, but they're just really like scrubby, and there's usually a lot of like shrubs growing in, like they're kind of open. Um, and so if it's sunny, like there's not a lot of cover. They don't have really like thick canopies. But like jack pine is the survivor, is how I always think of it. It can survive such harsh conditions. That's kind of why it can be in a place where there's not really fire to maintain it. And so like there's a bog like up Fraser Creek that like has jack pine growing in it. I was just there 2 weeks ago, and the jack pine is still there. You don't think as jack pine is growing in a bog, but it's a survivor. It can handle really harsh conditions and low nutrients and no soil or peat. Yeah.
So I want to preempt another question, which is, so we talked a little bit about drought and the future, but I want to know, Matthew, maybe sort of starting with you, what about fire? Because it's obviously the history of fire in Acadia. People remember the fire. There are, people who experience the fire, and it's very at the front of mind for people here, maybe that it wouldn't be elsewhere in Maine. And so it's just a question people have. What about fire?
Yeah, it's a good question. Yeah.
You can bounce it to Kate if you want.
Well, um, it- I started my career as a wildland firefighter, and
Right, I forgot that. Yeah.
so I used to think I knew a lot about fire, and I think that a future big fire in Acadia or throughout the Northeast is certainly quite possible, quite plausible, just like these scenarios that I did explore. So I think the simulation modeling, I could have used fire as one of those scenarios. And in fact, at one point we discussed doing that, but I didn't. So yes, it's certainly, the short answer is yeah, it's possible. And how close are we to it? Is it a couple more months of drought, a couple more years of drought, and a bad windstorm, and what is it that's going to tip us over the edge into 1947 conditions again? It's a good question.
Want to say anything? You don't have to.
Yeah, no, I mean, it's a tricky thing. Like the possibility of it happening is not zero. It's a very small chance of it happening every year. Last year, there was a fire that was ignited by lightning, that was near Gilmore Meadow, if you know where that is, smoldered for a couple of days, went nowhere. And it was like during the driest part of the driest month that we had. So like, it is kind of hard to to then like imagine that happening, although we have the history of the fire of 47 where that happened. And I think we have a lot more firefighting abilities now. And I think there wouldn't have been a fire that was left to smolder for 6 days before like something was done about it. But it's hard to think about those really rare but potentially like large impact kind of events like Matthew was modeling, because it's like statistics is not designed to work with those things. Statistics is about like centers. You're talking about means or averages. You're not talking about the extremes. It's really hard to really model that. You have to use imagination really to do that and kind of predict, like, say this could happen and what are different scenarios where maybe something similar happened. But you're really just kind of like reading a crystal ball with numbers, if you can, like it's really challenging to do. And like the spruce fir forest is not a forest of fire. Like we wouldn't have these mossy spruce fir forests if fire was a big part of the system. And so there's not really reason right now to try, like, you wouldn't want to change the forest to a different forest type. Probably wouldn't have very much luck because spruce is showing like spruce has a lot of inertia right now. Like it is continuing to take over the forest, and like good luck trying to make it be something else, really.
So, one of the things I'm going to get, this is to you, Alan. So one of the things that I realized in writing the book, there is a chapter of fire, is like the forests were very different in the 1940s. Like they were still cutting pulpwood on Mount Desert Island for paper mills. So the forest was not the forest that we have today. The woods were very different and the land use was very different. And remember that most fires are started by people, but it speaks to, Alan, like, so, and I was kind of surprised at the extent of cutting pulpwood that was happening on Mount Desert Island, even after the creation of the park. And so how did logging continue here in the 20th century? And like, how does it shape the forest that we see today?
Well, it made a big difference in the Schoodic Woods section of Schoodic, that's for sure. That was owned by a big consortium. First, it was the Grindstone Corporation, which sponsored a lot of cutting, which was already bare, as I showed in one of them.
For what? What were they cutting for?
Kept on cutting, and finally an Italian consortium bought it and kept on cutting right down to, sometime in the 90s, cleared it out. And then after they'd cut all the trees, they floated an eco resort in which they were going to put a hotel right there overlooking Fraser Creek. And so there, a lot of things happen in that area. One thing I worry about with the fire, by the way, is with more and more windstorms, the blowdowns, at least in the woods around me, and certainly are increasing. A lot of dead wood lying around that didn't used to be at the time that they cut it all. There was some slash, but now there's so many blowdowns. I worry about the storms are actually increasing the risk of fire. But that's just by the way.
I get a new line of questioning.
Wait, did you want to say it? Yeah. Oh, okay.
I was going to let the previous firefighter take that first, but I'll take it. It's really the fine stuff that we care about. That's what's going to like create a fire and carry. It's the big wood, the dead wood. Like that's important habitat. It wasn't there because it was cut. Like trees were cut before they could die and become coarse woody debris. But that's good habitat for things.
That's not the tinder that's gonna.
That's not the tinder. Yeah. That will keep a fire going, but it's not going to start it and carry it.
More about fire in the book.
So, I think of national parks as these sort of pristine places that are sort of untouched by humans and that will not be touched by humans. And of course, that's not true. We've just learned about this intense and severe land use history here with all the logging and fire. And then we also haven't really talked about this, like immense number of visitors that come to the park to look at the trees. That's why you all here, right? and so how do we, and so now think about management in the future. How do we manage in the future, given all these visitors that are here, that have a say, that want to be part of these decisions, perhaps, and given this history of land use, that it hasn't been untouched by humans. It's very different than national parks in the Western United States, for example, because of this land use history. So does that change how we think about the future management?
Yeah, we know it's not a wilderness. You know it's not a
And
wilderness.
I do want to say that I'm not against cutting. I burn wood, like it's fine. So I'm not against logging or cutting wood. And so, right, like we do interact with the forest, like we interact as humans with all ecosystems. It's like part of being human is to interact with the rest of the world. And so I think for me, part of it is helping people see that this is a human landscape and that this is, the whole place is really a cultural landscape. And that's where I think a lot of our collaboration with Wabanaki communities is really insightful, because they're going to experience sort of what's their homeland in a much different way, and see it more as relationship, and less as sort of a walled off place. And so I think learning more about that cultural association, as well as our own cultural association, and sort of our own history, kind of helps, which is why I don't know if you're going to ask about the apple chapter, but the apple tree was one of my favorite chapters to write, because it just, right, apples are here because of people. And the reason we have all this amazing diversity of fruit that sustains us as humans is because people have to culture. Apples need people in order to be. And so they're present. There's a chapter on apple, and they're present in the landscape, and they're sort of symbolic of this other way of relating to places, whether they're parks or not. I mean, I do think that parks have different expectations, but I would point to, we just learn how healthy the forest is, and 4 million visits a year, that their coexistence is certainly possible.
Yeah, they're still there, and I think there is more apple trees than there are white pines in the Schoodic section, and they grow in the strangest places. They're a great thing to discover.
Yeah. I mean, trees, right? So we emerged as a species alongside trees. So we are co-evolved to be with trees, and so maybe that's part of why millions of us are able to sort of coexist with trees. So yeah. Other questions? I think we do have some audience questions, but if anybody has something they wanted to talk about before we get there.
Yeah, well, just thinking about like the forest and kind of like us as part of the stewards of the forest. So I don't just work in Acadia. I work in 20 parks from Maine to Virginia of all different land use histories and kind of park histories. And, I'm often faced now with like, man, if only we knew better 50 years ago that planting a bunch of bush honeysuckle for like wildlife habitat and like bank stabilization was a bad idea, because we have so many parks that are just covered in bush honeysuckle. And it's a species that's managed here to prevent it from getting out. And so in general, like when I'm thinking about what are best management practices, or what are the decisions we're making today that we're going to think about in 50 years of like, why did we do that? Or, I'm thinking about kind of the well-intentioned but not great decisions that we made in the past. And now we have a lot more data, we have a lot more scientists, and the science of forest ecology has really grown since then too. But right, like what are we going to be thinking of in 50 years? What are my predecessors going to be saying? Like, man, Kate Miller really had it wrong on this thing. Like, I'm trying to figure out like what was that thing that I had wrong, and that's kind of what keeps me up at night, I guess.
Just don't plant any Japanese knotweed anywhere.
Right. Yeah.
Oh. All right. Well, we do have just a few minutes for audience questions, and I would like to start with questions on Zoom. Thanks, everybody, for joining us from wherever you are.
Yeah, so one of the first questions on Zoom is about red spruce, and Kate, you noted how the abundance of red spruce is really increasing in all size classes in the forest. And can you maybe just speak a little bit more about how red spruce really affects other species in the forest, so other plants, birds, insects, etc.
Yeah, so my knowledge mostly stops at plants, so I'll just talk about the spruce of the plants, but I'm sure there are other, like Catherine knows a lot about a lot of things, so I'll let Catherine take the insects and birds part of it. But what's kind of interesting is like spruce is really shade tolerant. It can grow under its own shade, and there really aren't a lot of species that can grow under spruce's shade. And when I think about like if we possibly lose spruce, and I know this isn't quite the question, but this is just something that's always on my mind, is that there aren't shade tolerant conifers that are south of us. Like there aren't southern species of like pines, for example, that are shade tolerant. They have a completely different ecosystem kind of function. They're early successional, they require disturbance, and they can't grow under their own shade. So it's kind of like spruce is it. Hemlock may have been that southern shade tolerant species, but we've got hemlock woolly delgid. So having such a dominance of spruce is it's a really unique species, but it also makes us really concerned if spruce can't hack it. But yeah, tell us about the birds and the insects.
I don't know insects as much, but I mean, I definitely, when I think about spruce, I think about the birds. So when I think about the spruce fir forest, I think about warbler migration in spring. And I think about at Fraser Point, which is one of the places where we monitor bird migration, and it's a hot spot because there's like this diversity of habitat. They love the apple trees, especially when they're flowering, because there's a lot of bugs in the flowers. But it's really the big spruces that are just dripping with warblers during the peak of spring migration. And there's just a lot of research on how those bird populations has already shifted. But when I think about the forest changing, I think about, Blackburnian warbler, magnolia warbler, black-throated green warbler, and all of those birds that, whether you know it or not, really create the feeling of being in the forest of Acadia.
And I have to say, a lot of those spruces at Fraser Point are quite new.
Yes.
Because some of the photos I had are absolute clear cut of that whole area. And in 1930, when they first began to build the park. So it's amazing how clear it was. And now some of these beautiful spruces that you're talking about are
and some are white, right? Because white spruce grows faster,
right?
And it fills in that old field. And so some of them are white spruce. Another question on Zoom, or should we? I saw one over here, but Nick, what?
One other one online, and then we'll do some questions in the room here. Kate, you said that a messy forest is a healthy forest. Forests that look like your teenager's bedroom are a healthy forest. So the way I think of it, why is messier better?
Yeah, so you're creating space for other things to live. So probably not everyone's aware of this, but a lot of tree species are actually adapted to regenerate on dead wood. If you've ever gone to an old growth forest where there's dead wood everywhere, you realize why that used to be a very successful strategy. Was there's dead wood everywhere. The dead wood, it has more moisture than just like the forest soil by itself. And that dead wood, it's messy, its trees fall and they're kind of overlapping each other, but that's creating habitat for other things to grow on. Mosses grow on the dead wood as well. That creates even more of a buffer against drought. And then also just like birds have places to perch or insects have places to perch. It's kind of like if you think about if you start with just like a single tree stem, like every tree stem is the same size, it's just kind of like there's only one level of structure, but once you start getting regeneration, you start getting trees that are older and taller and some that are younger and shorter, like there's so much habitat there, so much more habitat there. And in a way, it's a more resistant to like wind disturbance or something, or resilient to some kind of disease, because generally like that would hit like one age cohort. Or say a strong windstorm would hit all the tall trees, but if you still have some like sub-canopy trees there, they're going to be able to persist and they'll take over the canopy after that. So it's just kind of like, it's both like more places for things to grow, but also kind of hedging your bets so that there's like, it's not just one generation of trees or one species of trees out there, you have multiple.
Questions from the audience? We do just wait for the mic, so if you could raise your hand and a mic will, there's one here, come to you, just so that our friends on Zoom can hear. Thanks.
Hi, this was just terrific. Really, really great. And thank you so much. And really a reason to be doing the science because, you know, you hear different stories and so on. And I'm trying to resist my desire to ask a question about fire because you guys don't want to talk about it. But I want to ask it a different way. I am really struck. I mean, whether it's the superintendent and people don't seem to worry about it. Yes, they worry about it. They think it's, you know, but we'll fight it, we'll deal with it and so forth. But I am struck in Canada seems like it's an even better climate for preventing fires. You know, it's you think about Nova Scotia. I think of Nova Scotia. I've always thought of Nova Scotia as kind of us on steroids with a lot more fog. And now that's probably not fair, but they got decimated and it, you know, goes throughout Canada. There are continuous fires and, you know, of course we deal with it. Now it made me, part of it I realize is not a huge percentage of Canada. It just the smoke, but it feels to me like that's a bigger event and that we ought to be concerned about it. And especially feels like it's a bigger event if we get more, you know, fewer and fewer diversity of species. So I just, you know, what am I missing, I guess?
I would say it's not that we're not concerned about it. And there are things that we can all do about it. So one is like, if you live in the kind of wildland urban interface, is like thinning around your property and removing the like coarse woody debris that you're talking about so that it's not going to burn to your house. But like, that's not how park manages a forest. We're managing under, you know, forest for natural processes. There's a lot of planning that goes into how to respond to different scenarios. And you know, the forest seems similar to what's going on in Canada. That's certainly like concerning to see what's going on. You know, it's one thing when it's going on in like way northern Quebec or something, but when it's in Nova Scotia, you're like, oh my gosh, like is this us? Like what? The forests are different. They're younger. They're logged more frequently. They tend to be more jack pine than spruce, and so there are some differences. It's hard to really know. We're still figuring this stuff out. You know, like we are in novel times. There's no like manual that says like this is what you do now, this is what you do tomorrow. We're trying to figure it out the best we can with the best science we can, and doing the best we can to the forest, because if the forest burn, the forest is going to come back. It showed us that already, you know, like the forests are coming back in Nova Scotia. It's really about how's it going to affect the people that are living near the forest. And, you know, we're concerned about that, but also like we have to manage the forest for natural processes. So.
I would add, I agree. I think you bring up a good point, that we should be concerned, and indeed we are. And just to highlight again that fire, it is a natural process. And on some level, fire in Acadia has happened in the past and will happen in the future. And sort of how we humans work with that will be part of it. But sort of thinking about, you know, are there future scenarios where wildfire can be natural in the park, which is really challenging.
And the Wabanaki learned how to use it carefully and productively.
Exactly. So you know, that's where my mind went to sort of thinking about these kind of natural processes. Can, you know, again, I'm a scenarios person. I think about sort of different scenarios and different future ways that we could use fire rather than just fight it.
Other questions from the audience? Just a couple over here.
Hi, I'm wondering if with your research, you're doing any core samples to triangulate with the data you're collecting and the photographs you're taking to find out more about the history of the individual trees.
Tree cores,
Tree
right?
cores?
Yeah.
Yeah, so we have cored trees on outside of all of our plots, so we have like a rough stand age estimate. But there's also work at the University of Maine that's doing even more intensive work in the spruce fir forest outside of just Acadia. So like the coastal spruce fir forest, where they've cored a bunch of trees. They have these really cool dendrochronometers that are measuring like minute by minute, like tiny microns of growth and shrinkage, and then have weather stations out to look at the weather and how that's changing. So there is active research going on all of this. For us, the coring that we did in Acadia, it kind of just told us what we expected. Like we knew the forest mostly came back after the fire on the east side. There are some like large oaks that have big fire scars on them that have persisted. Like they were much older. They were all hollow, so we couldn't get ages out of them, but they went back before 47. And then on the west side, there are a couple of stands, west side of Mount Desert Island at least, there are a couple of stands that took a while to become forest again. And so we saw that like they were protected long before they became forest. So there's old field succession. And in there you can see, this is off of Seal Cove Road, you can see some kind of open grown spruce trees with the really long, wide branches. And those are the stands that they took longer to fill in. And our tree cores tell us that. So.
Okay, one more question.
Hi, first of all, thank you so much for your presentation. I think all of your unique perspectives and backgrounds really made it very interesting to listen to. I had a question about one of the bullet points I saw on the side, and I think it mentioned acid. And overall, just I was wondering about like, are there still traces of like the lots of human impacts that from that we talked about the logging that we still see today? Or yeah.
Yeah, like acid deposition. Yeah, so that was like acid rain deposition, atmospheric deposition. So this is a really cool story about Acadia that I don't think we tell enough. That so we're not just monitoring forests, but we've been monitoring the water and the air for longer than we've been monitoring the forest. And so we've been monitoring since the Clean Air Act was put into place. And we have seen like the waters and the precipitation, like the pH in the rain is higher than it used to be. The pH in the water is higher than it used to be. This is recovery from acid rain. Like it worked. The Clean Air Act worked. And now we're seeing that recovery in the forest as well, in the forest soil chemistry, but also red spruce is really sensitive to atmospheric deposition. And a lot of research in the Northeast has shown that now that that's not happening as much, that red spruce has been released and responding and like growing. And that's part of the signal we're seeing too, is their increase over time. So it's like, I don't get to talk about hope a lot, you know, it's kind of hard to be a biologist these days, but like that's one of the ones that like it actually worked. Like we can do these things. We can do big things and do good things.
Good place to end it. Thanks so much, everybody, for coming.
So a big thank you, to everybody for joining us tonight. And Catherine mentioned, one of the major threats is just being disconnected from our natural world. And so everybody has homework, and that is to get out and go for a walk in your favorite forest and to become more connected to that place. And I think we're all more connected than we even realize to our favorite forests, our favorite trees. And of course, when you're out there, those trees, they're photosynthesizing, and one of the byproducts of that is oxygen. And so as you're breathing, walking through the forest, you're breathing in oxygen that's been released from one of those trees. And as you're you're perhaps laboring up one of those hills that you're hiking on, and you're breathing heavily, you're exhaling lots of carbon dioxide. And those trees are taking in that carbon dioxide through the pores in their leaves, in their needles. And that carbon dioxide becomes sugars through the photosynthetic process that the trees then create and ultimately become some of the wood that they put on. And so when Kate goes out to that plot that she's visited 6 times over 20 plus years, then she's measuring diameter of trees. Those trees have some of that carbon dioxide in them that she exhaled from a previous visit. And so I'll do enjoy, get out, find a tree that you like, give it a hug. Thanks all for coming tonight, and we hope to see you again soon. There's still lots of great events upcoming. Do check out our website and the calendar page. We have the Maine Outdoor Film Festival returning at the end of the month, which is a fabulous evening of outdoor adventure and conservation films under the stars outside Rockefeller Hall. We also have our September evening lecture called Sky Watching, Human-Bird Relationships Through Time. So we're going to go from trees in August to birds in September with 3 amazing scientists and naturalists. We also have a variety of astronomy and painting workshops as well. And so please do check out our website to find out more. Thanks all for being here and travel safe.
And come buy some books.